Hello, my name is Joe Kratochvil. I'm a laser applications engineer in the New England office. Today we'll be going over switching from guide bushing mode to guide bushing list mode on an L220 Citizen machine. So we'll start off first with just looking at the front of the spindle inside the cutting room, the difference between the two. We have some characteristics of guide bushing specification, excellent stability of workpiece. We hold a tighter tolerance. It's got a 205 millimeter Z1 stroke. Guide bushing list specification, we have a shorter remnant, 55 millimeter Z1 stroke. We're able to use non-round bars and still hold roundness. So starting to switch from guide bushing to guide bushing list mode, the Z1 axis needs to be retracted to its limit. Once retracted, we can remove the 3 bolts from the connection block A, and then remove the 2 belt cover bolts, followed by the 4 spindle cover bolts. Here's a picture of the belt exposed once the covers are removed. And then we can loosen the tension bolt.
Can you tell them what specific machine this is?
Yep, this is on a L220 type 12.
Okay, thank you.
Yep. So from here, this point, we're going to loosen the tension bolt and then loosen the 2 fixing bolts. The fixing bolts are very tight. I tend to use an 8 millimeter longer length Allen key with like a wobble on it, and then a socket wrench. Those kind of help you get leverage on those 2. And then next, we're going to loosen the guide bushing drive device or spline shaft and move that towards the spindle. That's going to give the belt slack and then help us take it off. These retensioning bolts should never be loosened. They're set at the factory to allow you to retension the whole unit properly. So from this point, we have to take the coolant block out. And then we go to removing the guide bushing device with these 4 M8 screws. One's behind the coolant block, so once that's removed, you can get to it. Once the 4 bolts have been removed, we can take the device out. I like to use 2 M8 by 120 bolts as jacking screws because the tolerance on the guide bushing is very tight. It doesn't really slide out too easily. So gently tightening the bolts between 2, alternating, and it kind of frees itself pretty easily. Once it kind of starts to come loose, you really want to keep your hand underneath it because you can drop it, and that's a lot of money. So once we remove the guide bushing device, air is going to come out of the bottom hole for purging the guide bushing. There's a M6 by 10 set screw that's supplied with the machine. That needs to be placed here. Back in where the spindle is, we need to remove 4 holding bolts for the flange cover. It's kind of in there decently. What I like to do also is thread 2 of the bolts back in at 3 and 9 o'clock. It kind of gives you something to grab onto while you kind of wiggle and move that out of the way. We need to go into the cutting room, remove the belt cover from inside the machine. Once that's removed, then we can remove the belt and reinstall the belt cover. Once the belt cover is reinstalled, we reinstall the coolant block. Moving back to the spindle, we can now take the belt off the spindle pulley and then gently slide the guide bushing drive device back against the 2 retentioning bolts. Once that's against those, we can retighten the tension bolt so that the guide bushing drive device is fixed against the retention bolt. Once the guide bushing device is fixed in that position, we secure it by tightening the 2 securing bolts there and there. Once that's like that, we can loosen the two fixing bolts of the belt hook. And then we move to slide the guide bush and drive device forward and place the belt up on the hook. Remove the securing bolt, which is there, from the securing plate. We use this bolt to secure the guide bush and drive device when it's forward. And while we push the belt hook up to remove slack from the belt, we then tighten the two fixing bolts.
Hey Joe, we have a question. Do any of these bolts have torque specs?
I didn't notice any of them in the manual, nor have I found any of them. They're just kind of tight, if you will. Just not, you know, you don't want to really crank them down, but tight enough that they're not going to vibrate loose.
Thank you.
Yep. So once that's up and out of the way, we can install the spindle cap over the collet cap for our guide bushingless mode. And then in the MC structure, we need to go in and specify guide bushingless specification. So we go into our MC structure menu, toggle down the GBL specification, and we need to use the menu key and go up, and it needs to be set before we input. Once that's done, we need to power off the machine and power on, because the setting isn't saved until it's powered off and powered back on again. These are just all the pieces and bolts removed when going to guide bushingless mode. Again, it's nice to see them laid out. I like to bag everything and keep it organized when I take it out, so it's there when I need to put it back in. And MC data settings. The machine length, safety position, or start position safety amount value is going to be your part length plus your largest tool shift. And then with a cab on your machine, the work length and cutoff tool width is going to be the value depending on what cutoff tool you're using. If you're using a right-hand cutoff tool, it will be your part length plus the tool insert width. If we're using a left-hand cutoff tool, it's going to be your tool shank plus your part length. Again, that's only on if you're using a cab bar loader. Use of the stopper. Again, it's another thing that needs to be set in the machine structure before you can designate it. Again, in MC structure, we need to go in, toggle down to it, set, and then hit input. Should power off and turn it back on, again, to make the settings valid. And setting the stopper in the MC data, the stopper can be set in any position as long as it's tool 20 or tool 1 through 5. An available stopper can be purchased as an option for the L220E. Part number is L220E-U61C. And then if you're going to use a stopper, the tool number must be entered in the stopper number box in the MC data. If you're using the cutoff tool as a stopper, a 0 would be input into the stopper number box of the MC data page. You would be fine putting a 1 in as well, but usually we use a 0. Cutoff example using the stopper in the T2000 position. This program's right out of the book, and it's only using G600, no G650, but it's brief and it's to the point enough where in the beginning of the program we can see that $1 we're in start position using the stopper in T2000. The main collet would open and Z1 axis moves to machining length. When the collet opens, the stock is pushed out against the stopper at the same time via the bar feeder. Then the collet closes. The machining operation is done on the part, followed by the pickoff and the cutoff. M141 is called to send sub spindle to home position. With the main collet still closed, the Z1 axis goes to start position. Since the part was cut off, then moved to start position, a gap was created between the stock and cutoff tool. Now the stopper is indexed to position in front of the stock, and then M99 is called, and the program returns to the top to start the next part. If using G650 and anything other than the cutoff tool for stopper, In the beginning of the program in $1, the main collet must be opened and Z1 moved to a machining line. When the part is cut off, picked off, is complete, start position is then done, and then whichever tool being used as a stopper can be indexed. If using the cutoff tool as a stopper, the cutoff and positioning afterwards is programmed the same way if using the machine with the guide bushing installed. So a standard cutoff pick-off in your program as you normally would. And then I have on the next page just a continuation of this program, just showing you where the stopper is called after start position and so on and so forth. Next, so switching back to guide bushing specification is pretty much in reverse order of how we took it out, with a few different things done to it. So first thing we need to do is go back into machine structure and change it to rotary guide bushing device. The reason being is Z1 axis won't move back far enough for you to get in there with it in guide bushingless mode. So we go on our MC structure page, we go into synchronous rotary guide bushing mode, and then power it off, power it back on, and then those settings are now made active. So first we remove the spindle cap, and then the fixing bolt holding the connection block to the securing plate. That's just the securing plate. Loosen the two fixing bolts holding the belt hook, and then remove the belt from the hook. Once the belt's removed, we can tighten the two fixing bolts and thread the fixing bolt back into the securing plate. After that, we loosen the tension bolt and then two fixing bolts there, and move the guide bushing drive device or spline shaft towards the spindle. We slide the connection block down the spline shaft toward the spindle and then rotate the block away from us and then place it on the spindle. Again, never loosen the retensioning bolts. They're set by the factory, and it's going to cause you a headache if you touch those. So once the connecting block is back in line with the spindle, we can put the belt back on to the spindle pulley. We're not going to tighten any of the fasteners at this point. We're going to go back into the cutting room, remove the cooling block, remove the belt cover, and then mount the belt to the pulley. Leave it like that. We need to remove the socket set screw as soon as we're with the cover off, because if you forget, that guide bushing is not going to go back on correctly. So we remove that. Air is going to come out of that hole as soon as it's removed, and then we store that set screw in the tapped hole in the casting that's right next to the belt hook back in the spindle area. With the guide bushing device in your hand, you're going to reach into the machine and slide the pulley end of the guide bushing into the mounting hole. With the other hand, we're going to slip the belt over and onto it. Once that belt is on there, we can then tighten the securing bolts of the guide bushing device. I like to work back and forth just to make sure everything's in there flat and against everything appropriately.
Joe, we have a question.
Yeah.
Does the bar feed know when you use non-guide bushing and auto compensate, or do you have to adjust parameters?
It should know when you change to guide bushing list mode in the MC structure. If someone else knows more on that, please feel free to try and speak up.
Well, there's all different bar feeds, so there's cav and not cav, but our cav does have two different sets of parameters. So the oldest calves, we always had to change the parameters. They would get wiped out every time. I believe just now there's newer software, or soon there will be, so you don't have to check those parameters. And then other bar feeds, you actually have slide mechanisms that you could slide the whole bar feed forward or slide the whole bar feed back. So there's different versions on different bar feeders. But you should always check your setting by simply doing a test with no bar and bring the pusher up, and you can see your end of bar signal. So either way, an operator should always know he's got the proper setting with a simple test.
Thank you.
Okay, so moving on, we have our belt is now on our pulley. We can pull the guide bushing drive device spline shaft towards the two retentioning bolts and then tighten the tension bolt. That tension bolt really is just applying pressure onto those two retentioning bolts. So you can start to torque that plate if you over tighten it. So you really just kind of want to tighten it enough so it's really against those stops is what you're really trying to do. Then we're going to check that both belts, so J is attached to the drive bushing device, and that belt K, the one that's on the spindle, that they have pretty much the same amount of tension on them. Then we're going to turn the spindle by hand, make sure the guide bushing device rotates with the spindle. And once everything checks out good, then we can tighten the two fixing bolts to really secure everything in place. We're going to install the spindle cover. Oops, sorry about that. And secure the connection block to the headstock via these three bolts. Then we loosen the two pulley fixing bolts that secure the pulley to the connection block. Those need to be gradually tightened, alternating between the two. Once tightened, make sure that the assembly moves smoothly by moving Z1 axis forward and backwards. And we install the flange cover and tighten 4 bolts. Put the belt cover in place, tighten the 2 bolts. So those are the 2 bolts on top, the belt cover being B. We're going to go back in and close the belt cover and install the coolant block. I don't know what happened there. We just real. Just sorry, Joe. It just kind of jumped through
No problem.
half of my presentation here. So belt hook removed. Tighten. Yeah, belt hook. Yeah.
Looks like it went back to the beginning, Joe.
Yeah.
In the meantime, there is a question. Is the L20 conversion process similar or identical to the L12 and L32?
I haven't done it on the L32. I've done it on the L12, and it was pretty similar, other than the spline shafts on the other side. So it's kind of opposite, but for the most part, it's the same idea. The belt in the drive device is still sliding forward and getting mounted up on the casting.
Yeah, conceptual.
You're breaking up there, Brian.
It's 90% the same.
Brian, the first half of that was broken up.
I'm sorry. So it's basically 90% the same. Some of the machines have the drive shaft towards the operator, and some of the machines have the drive shaft back behind, just from different design, but it's virtually the same process to switch over.
Thank you.
All right, so we got as far as putting the belt back on. Again, sorry about this. We slid the belt back on. We retensioned our bolts there. Retension bolt 2 we checked that our two belts had the same tension. We connected our block. Okay, yeah, and then we did this. So this is pretty important. It designates it in the manual that there could be issues if you don't do this step. So we'll put the flange cover back in, tighten those bolts. We'll put the cover back on. We'll close that, put the coolant back on. And it looks like that was it. I tried to just go back and look through, and that was pretty much it. Randy, I mean, you saw this before.
Yep. So right now, just if anybody has any other questions.
I would like to bring up, since you have some time, you're a little early, can you go back to the programming section and highlight the stopper and things? And I would like to tell everybody who's watching, as you're on your screen, if you click on your screen, you can hit Control and the plus sign, and you can zoom in on what he's showing you if you want to highlight a section. And so if you would go to and review the exact stopper section and the ending section, please.
Yep. So, do you want me to do it in the 650 or in this one?
Yeah, go ahead and do both because you have
Okay.
time. Just you went a little fast here, go a little slower.
So in this is right out of the book here, but we have so in the beginning we retract the Z1 axis in the stroke required for machining. Then we come down, we do our machining. We move our workpiece away from, we move our workpiece away from the stopper first. Then we move to our machining. Once the machining's finished here, we're going to move to our pick off and cut off. We'll return, I'm lost here. So we do our cutoff, and then with the cutoff in place, the cutoff tool is still in place. We have a gap because we did start position. Once start position is done, then we index to our stopper. And then in the beginning of the program, we go with the chuck open, the bar stock will move forward to the cutoff or to the stopper again, and then move to machine length. And then in 650 mode, we have here, we're moving our collet open and then moving to our machine length here. Then we close our collet dwell and then move our way from the stopper. Then we go to our machining operations here and here, or I had machining operations in there, and then we go to our cutoff. Everything's kind of the same standard cutoff wise until we get to after the cutoff. Once the cutoff tool is still in place, we open the collet, move back to start position. No, we don't open the collet, I'm sorry. We move back to start position, then call the stopper. And that again pulls the stock away from the cutoff tool, indexes the stopper. And then back up at the top of the program is where we open the collet, move back to machine position.
What you have here is the G650 version he's showing you is using the cutoff tool as the stopper. So when you're using that, it's pretty much the same as what you're doing with the guide bushing. Because if that's the stopper, if it's strong enough to be the stopper, then you're going to open the collet, you go back to start position, you're all set. If you use the special option stopper, when you do that, you're pulling the stock back after the cutoff, so with the collet closed, so it brings the material away from the position where the stopper could hit it. Then you index to the stopper, then you just open the collet, and the bar feed will push the stock out up against the stopper, and you can close the collet and begin again.
We have two questions here, guys. When you said tension and retention screw, what do you mean? Do you need to torque on the bolts?
So the retention screw is what they call it in the manual, and those are the two that are factory set. The tension bolt there's no like torque limit to it. It's just pretty much pulling that whole guide bushing drive device towards those retensioning bolts, if you will. So those retensioning bolts that are set from the factory are pretty much dead stops.
And that tension bolt would be used if you needed to adjust the tension, or if you replace the belt, you might need to readjust it because it's a little bit different length to get the tension correct on that.
Correct.
Noted. There's another question. Our bar feeders are fitted with axial shift. Do you cover how they should be positioned when non-guide bushing mode is on?
I'll help you there. So the axial shift just has two positions. It has back for Swiss mode or away from the machine, or it has forward for non-guide bushing mode. And when we go into non-guide bushing mode and you push the button in the machine that says non-guide bushing, it actually changes our over travels. So that if you were to do it wrong and you were to feed back, you would actually get an alarm before you hit this moved forward bar feeder. The bar feeders have safety switches also, so that if you end up touching the switch, you get a e-stop, an alarm. So the bar feeders basically have two positions, the ones that do axial shift, forward or back. And that's it. And the rest of the softwares and the safeties come into play. That's all standard.
Thank you. There's another question. How long is the changeover time for an operator?
I've been able to do it with around like half hour. It could be less. Like if you've done it a couple times, I guess it becomes easier to do. But I would say like following the manual or even using this presentation to go through it shouldn't take you more than a half hour.
I would agree with that, but I'd say that the first time or a couple times you do it, it might be a little bit longer. But once you've done it a couple of times, then it gets pretty quick. It's pretty easy because you'll understand what it is you have to do.
There's one more question here. Our machine has a back cover on the main spindle. Do I need to remove that cover when using non-guide bushing mode? And can I use non-guide bushing mode on an L520 and L720?
The L520 and L720 did not have non-guide bushing mode. So the answer to those two is no. The black cover you're talking about on machines that do have the ability to switch to non-guide bushing mode, that cover gets replaced by another cover that comes with the machine that fits the seal that's around the guide bushing area where you remove the guide bushing from. So the black cover comes off and it gives you a different cover to put on there.
Thank you, Randy.
Yep.